Our first video for this particular chapter is going to be about negative exponents. This chapter in general is about exponents and polynomials, and so we'll be learning about that sort of thing. Polynomials are actually a very important part of math. You'll be learning a lot about them over the next several years, in fact. But anyway, you already know, I'm sure, that 2 to the power 4, that's something like that. That's just 2 times 2 times 2 times 2. The base is 2, the power is 4, the exponent is 4. Power exponent, of course, means the same thing here. And that just indicates how many 2's we're multiplying together. 2 to the 3, well, that's 2 times 2 times 2. 2 to the 2 is 2 times 2. 2 to the 1 is just 2. What's 2 to the 0? What's 2 to the negative 1? Or 2 to the negative 2. What do these negative or non-positive integer exponents really mean? Well, one way we can kind of figure that out is by following this pattern. If we are multiplying by 2 as we go up, so 2 to the 1 is 2, 2 to the 2 is 2 times 2, 2 to the 3 is 2 times 2 times 2, then the opposite of that, sorry, I wanted to get some new chalk. The opposite of that, going down the list, would be to divide by 2. So 2 to the 4 divided by 2 gives you 2 to the 3. Divided by 2 gives you 2 to the 2. Divided by 2 gives you 2 to the 1, or just 2. So if we continued that pattern, I would divide 2 by 2, and that would give me 2 to the 0, or simply 1. Dividing by 2 again to get 2 to the negative 1, well, that'd be 1/2. Dividing by 2 again gives me 1/4, or 1 over 2 squared. So this gives us one clue as to what's happening when we have a 0 or a negative exponent, but I'll give you another rationale using the rules of exponents that you either have learned about already or you'll be learning about soon. You've probably learned by now that when you have something like a to the 5 divided by a to the 3, that you can simplify the process of expanding out all of the 5's, all the 5 a's on top and all the 3 a's on the bottom and canceling, and just do a to the 5 minus 3 to get you a to the 2. We can use this idea then to help us define what a to the 0 would be, and for example, what a to the negative 2 would be. So let's do this one first. And the example I'll think about is a to the 4 divided by a to the 4. Now, expanding it out gives us 4 a's on the top, 4 a's on the bottom. They cancel, cancel, and we're left with just 1. But according to the rules of exponents, a to the 4 divided by a to the 4, well, that's equal to a to the 4 minus 4. And 4 minus 4, of course, is 0. So a to the 0 then must equal 1. We got kind of a transitive property kind of thing, which gives us then a definition. A definition of a to the 0 equaling 1. In general, then, this means that any base raised to the 0 power of 0, equals 1. Now, there's some things you got to be careful about here in this particular example when you're dealing with powers of 0. Make sure you pay attention to what the actual base is, because if you have something like, I don't know, 2n to the power of 0 versus 2n to the power of 0 without parentheses, you got to make sure that you pay attention to what the parentheses are telling you. The parentheses here are telling us that the whole 2n, that whole monomial, is the base of that. And the 0 is affecting both the 2 and the n. So that whole expression is going to evaluate to 1. But here, 2n to the 0 like this, there's no parentheses. The 0 power is only affecting the n, not the 2 as well. So this is going to turn into 2 times 1. The n is only converted into 1. The 2 is not actually being raised to that power. So this then is going to be equal to 2. So don't shortcut your brain and think that any time you see a 0 automatically means you get a power, it turns into 1. Only when the entire base is being raised to the power of 0 does it completely turn into 1. If not the entire base, if there's something else going on, then you'll have to deal with those steps. Let's talk about a to the negative 2 now. I'm going to erase this stuff, but pause it for a second if you need to write this down someplace, maybe on your paper or something like that. But I'm going to erase it now, so I have some room to work. Because now I want to talk about a to the negative 2 here. I'll move it up. A to the negative 2. And the example we'll think about is, well, a to the 3. Actually, we'll do something like that. A to the 3 divided by a to the 5. By our rules of exponents, that would give us a to the 3 minus 5, which gives us a to the negative 2. So that's how we can get a negative exponent, when the power on the bottom is bigger than the power on the top. But if we do the canceling, we get 3 a's on top, 5 a's on the bottom, and then they cancel. I have a 1 left over on top, and then 2 a's left on the bottom, so I'll rewrite that as a squared. And so this gives me a new definition. When I have a negative exponent, I flip the base. Because I could rewrite this as 1 over a to the big power of 2. After all, 1 squared is 1, and so that's not actually going to change anything. And so my rule, then, that we can call it, is that a negative exponent flips the base. We take the reciprocal of the base, whatever the base is. So if it's just a to the negative 2 is equal to 1 over a to the power of positive 2. If we had something else, like say 2/9 to the power of negative 3, the negative power means we flip the base to get 9/2, and we raise that to the power of positive 3. And so that would give us 9/2 times 9/2 times 9/2, which we could then multiply across and eventually be 9 cubed divided by 2 cubed. If you have a letter or anything like that, if it was 2x over 9, then it's 9 over 2x. Just be careful again about what your base actually is. If the base is in parentheses, then the entire base is being flipped. And of course, if it's a number like that, then that would just turn to 1 over 4 to the power of positive 3. Because of course we could write that as 4 over 1. So that's how a negative exponent works. We make it positive and then flip the base. Related to this, as another example, but not exactly the same thing, is when the base is already in a fraction. So the 3 and the b, they don't have negative exponents. They're not going to go anywhere. They don't change. We'll do the rest of this piece by piece. A to the negative 4. That would turn into 1 over a to the positive 4. But since this is already a fraction, it's easier to just put the a in the denominator. Since that's, after all, what would be happening if we had a to the negative 4. That's 1 over a to the positive 4. So we'll just put a to the positive 4 there on the bottom. This 2 to the negative 3 here becomes 2 to the positive 3 on the top. And this c to the negative 2 turns into c to the positive 2, again, on the top. And then this is 3 times 2 to the 3. 2 to the 3, of course, is 8. And I can actually multiply this across. I get 24 bc squared divided by a to the 4th. And so that would be our kind of most simplified answer there. 24 bc squared over a to the 4th, like that. These types of examples can get really, really tricky. There's some on your homework that are really tricky. Try them on your own. And if you're having some difficulty with, especially when the whole thing is being raised to a negative power, that can get really complicated. And if you're having trouble, check out the next video for a couple examples of things like that.